So zeros is a fancy name for several different things involved in graphing functions. Okay? One of the main things that zeros is it's the x-intercepts of the graph. Okay, so we're kind of learning about how to graph functions, how everything pertains to graphs of functions, right? But in addition to it being the x-intercepts of the graph, zeros are the solutions to an equation. Oh, my handwriting is off kilter on my tablet today. When the value of a function is 0. Like I said, I think I have a filled-in version of these notes, and so if you're not reading my handwriting very well, you could refer back to that. Okay, another name we sometimes use for zeros is the word roots, because the zeros give us the roots of a function or of a polynomial function, and we can use those roots to create the function itself if we don't know what it is. And we'll be doing more of that in chapter 2. I do have just a little example written here with regards to all 3 of these items. So let's throw an example, and I didn't type it in there, but I'm just going to have it. Sometimes my pen skips a beat here. Okay, f of x equals x cubed plus 2x. Our instructions are we are going to find the zeros. I don't know why my computer is hiccuping on me here. It's like not letting me write smoothly. It's rather frustrating. Find zeros. I wonder if I need to try stopping my video and try. I wonder if I like turn off my own video, because I don't think I need my camera going. You just need to be able to hear me and see my screen. So maybe if I turn off my own video, it'll help it not be so jittery, like take less of my system to use it. Experiments. Okay, here's our example. Let's see if this is going to work a little better. So we've got the equation 3x plus 2x. We want to find the zeros. So to do that, we are going to do the second item I listed here. The zeros are the solutions to an equation when the value of the function is 0. So just like we were kind of solving the problem at the beginning today from example 1, we're going to go ahead and set this equal to 0 and find the solutions, because those are the zeros. So if we can factor it, it's always good to factor it if we can. So factoring it, we would be able to factor out an x, which leaves us with x squared plus 2. Now, if we use our zero product property, we would just take each of our factors. So x as a factor equals 0. I didn't do anything else with this factor because it doesn't factor any further. It's like a sum. There's no way to factor this quadratic. So I'm just going to take it the way it is and set it equal to 0 and solve it. And for this particular example, I don't know if you remember imaginary numbers very well, but we would be doing plus or minus the square root of a negative number, which means it would give us 2 imaginary zeros. So hard to believe that zeros can be imaginary, but they can. So this is what we're gonna learn all about this in chapter 2, but this is stuff you probably learned in secondary 3 last year if you remember any of it. that is that the highest power of this function is 3. We call that the degree of our polynomial function, and if it has a power of 3, then that means it has 3 zeros, which this one does. It has x equals 0, and it has plus or minus 2i. So the zeros are, I'm just going to write them out to make it clear as to what the zeros are here. The zeros are 0, positive 2i, and negative 2i. So we have 3 zeros, but we only have one real zero, so there's only one x-intercept, because imaginary zeros cannot be imaginary zeros cannot be on the graph as x-intercepts. They just kind of indicate places where the graph is maybe like looping around but not crossing the x-axis. So the only x-intercept is at 0, because that's the only number that's real. The other are imaginary. In fact, if we try graphing this, we get something. Well, I have a sketch. I'm not sure it's entirely accurate. So it's going to look similar to just a regular x cubed graph, with it going through 0, 0. But without me actually graphing it to verify this, it's possible that because of those imaginary zeros, whoops, stray mark there, that it might actually like do this little like loop-de-loop thing in there. Does that make sense? So it's not crossing the x-axis, it's not x-intercepts, but it still is an indicator of something else happening because of those imaginary zeros. So, like I said, we'll go into that in a lot more detail when we get into chapter 2. So that was just kind of a preview of things to come and applying that to the concept of zeros. All right.